చేస్తారు చూస్తుంటారు సార్ సార్ మాకు
Okay. Good morning, all of you. Today's our remaining part, class of motion. In the class of motion, first one is connected bodies. Connected bodies. Here we consider three blocks of masses M1, M2, and M3 connected by two strings. Tension between M1 and M2 is T1 and tension between M2 and M3 is T2. Now we applied external force F on block M3. Here one important thing is if three blocks on smooth surface, three blocks having same acceleration, three blocks having same acceleration. From Newton's second law, F equal to m1 plus m2 plus m3 into a. Therefore, acceleration a is equal to F by m1 plus m2 plus m3. This is acceleration for each bodies. Now tension T1 in between M1 and M2. Here T1 pulls only one block M1. So T1 is equal to M1A, that equal to M1 into, here A means F by M1 plus M2 plus M3. Therefore, tension in the string T1 is equal to M1 F by M1 plus M2 plus M3. And also find tension T2. Here T2 pulls three blocks M1 plus M2. So T2 is equal to M1 plus M2 into A. That implies M1 plus M2 into, here A means F by M1 plus M2 plus M3. Tension T2 is equal to M1 plus M2 into F by M1 plus M2 plus M3. So this is acceleration and tension T1 and tension T2. One example problem. Consider two blocks having same masses. Two blocks having same masses M. We applied a force F on block A. A wire connected between A and B. Here tension T in between A and B. Find tension in the string. Here acceleration A is equal to F by M plus M to M. This is equation 1. Now tension T is equal to MA. So M into A means F by 2M. Will be cancelled. Therefore, tension in the string T is equal to F by 2. T is equal to F by 2. And another example, consider three blocks. Consider three blocks of different masses. For example, this is A, B, and C. Here we applied a force T3 is equal to 36 Newton. Three blocks are connected by two strings. Tension between A and B is T1 and tension between B and C is T2. Here mass of A is 1 kg and mass of B is 8 kg and mass of C is 27 kg. Find the acceleration of the block and find the tensions T1 and T2. Here acceleration A is equal to F by total mass M1 plus M2 plus M3. 27 28, 36. Here F and T3 is same. So 36 by 36. That means acceleration A is equal to 1 meter per second square. Now tension in the string T1. T1 is equal to M1A. M1 means 1, acceleration 1. So 1 Newton. And tension T2 is equal to M1 plus M2 into A. 1 plus 8 into A. 1 plus 8 means 9, acceleration A. So T2 is equal to 9 Newton. This is another example. And also example 3. Suppose we have three blocks of masses M1, another block of mass M2, and another block of mass M3. We applied a force F inclined theta to the horizontal. So tension T1 in between M1 and M2, T2 is between M2 and M3. Here mass of M1 is 2 kg and mass of M2 is 10 kg and mass of M3 is 12 kg. Find the ratio of T1, T2. Find the ratio of T1, T2. So from this diagram, T1 is equal to M1A. That means 2A, equation 1. And T2 is equal to M1 plus M2 into A. M1 plus M2 into A. That is equal to 12A. That is equation 2. That is equation 2. So ratio of T1 T2. T1 by T2 is equal to 2A by 12A. 2 ones, 2 sixes. So T1 by T2 is equal to 1 by 6. These are connected bodies. And second obligations, Atwood's machine. And second one, Atwood's machine. Atwood's machine means we consider a rigid support or ceiling. From this one, we take a pulley, a string placed on pulley. So here M1 is mass of one block and another side mass M2 and another side mass M2. Here tension T is always towards point of suspension and weight of mass M1, weight M1G always downward direction and M2G also downward direction. Here one condition is M2 greater than M1. Here condition is M2 greater than M1. So M1 moving upwards with acceleration A and M2 downwards with same acceleration A. So from this diagram, M1 moving upwards. Already we know apparent weight of a person in a lift and also tensions. In that cases, we have body moving upwards with acceleration will be taken as G plus A, downwards G minus A. So from this diagram, tension T is equal to M1 into G plus A. T is equal to M1 into G plus A. From this equation, T is equal to M1G plus M1A. This is equation 1. And also from this one, tension T is equal to block moving downwards. So M2 into G minus A. So T is equal to M2G minus M2A. This is equation 2. Here we are also discuss using free body diagrams. Free body diagram means we consider a block of mass M1. Here two forces, tension upwards and M1G weight downwards. So resultant force F is equal to T minus M1G. From that also, from Newton's second law, F is equal to Ma. Here mass is M1. That's why M1A is equal to T minus M1G. From that equation, T is equal to M1G plus M1A. In the same way, free body diagram for M2, tension and M2G are in opposite direction. So net force F is equal to M2G minus T. So from Newton's second law, F is equal to M2A. So from that equation also, T is equal to M2G minus M2A. From equations 1 and 2, M1G plus M1A is equal to M2G minus M2A. This M2A become this side plus. So M1A plus M2A is equal to M2G minus M1G. Here A will be common. So M1 plus M2. Here G will be common. M2 minus M1 into G by M1 plus M2. So acceleration of each block A is equal to M2 minus M1 by M1 plus M2 into G. Acceleration A equal to M2 minus M1 into G by M1 plus M2. That acceleration will be substituted in equation 1. So T is equal to M1G plus M1 into A. A means M2 minus M1 into G by M1 plus M2. Here M1G will be common. So LCM M1 plus M2 plus M2 minus M1 by M1 plus M2. Minus M1 plus M1 will be cancelled. M2 plus M2, 2M2. Therefore, tension in the string T is equal to 2M1 M2G by M1 plus M2. Tension in the string T is equal to 2M1 M2G by M1 plus M2. And also, if the block M2 initially at rest, find the distance traveled. Find the distance traveled. From equation of motion, S is equal to ut plus half at square. Initially at rest means u is equal to 0. So S is equal to half into, here A means acceleration. Acceleration M2 minus M1 by M1 plus M2 into G into T square. So this is distance traveled by the block. S is equal to half M2 minus M1 by M1 plus M2 G into T square. So that is distance. And also here we have to find the force on the pulley. Find the force on the pulley. Here we consider a pulley and string. This is tension T and this is tension T. So tensional force T dash. From this diagram, T dash is equal to 2T. T dash is equal to 2T. Therefore, T dash equal to 2 into T means 2M1 M2G by M1 plus M2. 2M1 M2G by M1 plus M2. Therefore, tension in the pulley T dash is equal to 4 M1 M2G by M1 plus M2. Tension T dash equal to 4 M1 M2G by M1 plus M2. So these are two cases. And another important case, if one block is on a horizontal table and another block is suspended by the string freely. If two blocks, one is on horizontal surface and another one is suspended by a pulley. For example, we consider a diagram. Here we take a pulley. One string is like this. Suppose a block of mass m1 and another block of mass m2 suspended like this. In this also tension T towards point of suspension. Here tension T. So this block here condition also M2 greater than M1. M2 greater than M1. Here also acceleration is like this and this block acceleration downwards. So weight mg always downward direction. From free body diagram, from this tension T is equal to m1a. Tension T is equal to m1a. This is equation 1. From this diagram, free body diagram, m2g minus t is equal to F net force m2a. From this equation, t is equal to m2 into g minus a. This is equation 2. From equations 1 and 2. From equations 1 and 2, m1a is equal to m2g minus m2a. Minus m2a becomes plus. A will be cancelled. A into m1 plus m2 is equal to m2g. Therefore, acceleration A is equal to m2g by m1 plus m2. Acceleration A is equal to m2g by m1 plus m2. So this is acceleration the block. Find the tension in the string. So this acceleration will be substituted in equation 1. In equation 1, tension T is equal to m1. A means m2g by m1 plus m2. So tension in the string T is equal to m1 m2g by m1 plus m2. Tension T is equal to m1 m2g by m1 plus m2. Acceleration is m2g by m1 plus m2 and tension in the string T is equal to m1 m2g by m1 plus m2. And also we have to find tension in the pulley, tensional force in the pulley. Here we have two forces along this one tension T, angle between them is 90 degrees. So T dash equal to square root of T square plus 2 square plus 2T cos 90. Cos 90 will be 0. So T dash is equal to root T. T dash is equal to root 2T. Here T is equal to M1 M2G by M1 plus M2. So tension on the pulley T dash is equal to root 2 M1 M2G by M1 plus M2. Tension in the pulley T dash is equal to the force on the pulley T dash is equal to root 2 M1 M2G by M1 plus M2. And another application, inclined right angle triangle. We consider like this. A block is placed on inclined surface. Here theta is angle. So inclined surface of mass m. Here we consider a pulley, a string suspended like this. This is m1 and here a block of mass m2. Here also M2 greater than M1. That's why tension T towards pulley. So M1G resolved into two components. Weight always downward direction M1G. This is a normal reaction N. Normal reaction balances M1G cos theta, and this one is M1G sin theta. Here tension T and M1G sin theta are in same and opposite directions. Two forces and opposite directions. So M2G downward direction. Here acceleration of M1 is like inclined and acceleration of M2 is downward direction. So from this diagram, here free body diagram, we consider a mass M2 and tension T and weight M2G downwards. Its acceleration is downwards. So net force F is equal to M2G minus T. From equation Newton's second law, F is equal to MA, that equal to M2A. So tension T is equal to M2 into M2G minus M2A. This is equation 1. From this one, free body diagram. Here tension T and balancing M1G sin theta, acceleration is upward. So from free body diagram, F is equal to T minus M1G sin theta. If F means M1A, M1A equal to T minus M1G sin theta. T minus M1G sin theta. From this one, T is equal to M1A plus M1G sin theta. T is equal to M1A plus M1G sin theta. This is equation 2. From equations 1 and 2, M2G minus M2A is equal to M1A plus M1G sin theta. M1G sin theta. This M2A becomes this side. So M1A plus M2A is equal to M1G sin theta. M2G minus M1G sin theta. So here A will be common, M1 plus M2. Here G common, M2 minus M1 sin theta into G. Therefore, acceleration A is equal to M2 minus M1 sin theta into G by M1 plus M2. So this is acceleration of the block. A is equal to M2 minus M1 sin theta into G by M1 plus M2, and tension in the string. So this acceleration A is substitute in equation 1. We get tension T is equal to M1 M2 into 1 plus sin theta into G by M1 plus M2. On solving, we get tension T is equal to M1 M2 G into 1 plus sin theta by M1 plus M2. This is tension. So here acceleration A is equal to M2 minus M1 sin theta into G by M1 plus M2. And tension in the string T is equal to M1 M2 into 1 plus sin theta into G by M1 plus M2. Here also find the tension on the pulley or force on the pulley. Here we have two forces and angle theta. This is 90 degrees and the remaining angle 90 minus theta, and remaining angle 90 minus theta. Here tension T like this, tension T. Here we have two identical force. In parallelogram law of vector addition, if T dash is a resultant, T dash is equal to 2T cos theta by 2. Here T means 90 minus theta. Therefore, force on the pulley T dash is equal to 2T cos 90 minus theta by 2. T dash is equal to 2T cos 90 minus theta by 2. This is one of the important application. And another application we have two angles, base angles. So this is alpha and this one is beta. Alpha and beta. Here we consider a pulley and one string is like this. So this side of mass M1 and this side connected mass M2. Here M1 greater than M2. Here M1 greater than M2. So this block moves this side and this block moves upward. So tension T always towards point of suspension. So weight M1G sin alpha. Here M2G sin beta. M1G sin alpha and M2G sin beta. From this also free body diagrams. M1G sin alpha minus T is equal to M1A. That is equation 1. From this one, tension T minus M2G sin beta is equal to M2A, equation 2. Adding equations 1 and 2, P will be cancelled. So G also common. M1 sin alpha minus M2 sin beta into G is equal to A common M1 plus M2. Therefore, acceleration A equal to M1 sin alpha minus M2 sin beta by M1 plus M2 into G. So this is acceleration of the block. A is equal to M1 sin alpha minus M2 sin beta into G by M1 plus M2. And also that acceleration substitute in equation 1 or 2. In equations 1 or 2, we get tension T is equal to M1 M2G into sin alpha plus sin beta by M1 plus M2. Tension T is equal to M1 M2G into sin alpha plus sin beta by M1 plus M2. So these are the applications on pulleys. Here also we have tried to find one or two problems. So example 1. Example 1. Here a pulley of two blocks of masses M. Here another block of mass 2M. So this is diagram 1. And another diagram, we consider a pulley, one side mass M and another side pulling force 2mg. So this is second diagram. From equation 1 and 2, find acceleration. Find acceleration in two cases. So from first diagram, once again I will explain this one. A block of mass M lifted by connecting 2M to the other end of the string. Find the acceleration of the block. Once again, small m lifted by another mass to m connected to other end of the string. Find the acceleration a. Here this is like Atwood's machine. Atwood's machine. Acceleration a equal to m2 minus m1 by m1 plus m2 into g. Acceleration a equal to m2 minus m1 by m1 plus m2 into g. Here m2 is 2m minus m. 2m minus m means mg by m plus m plus 2m 3m, mm cancel. Therefore, acceleration a is equal to g by 3. Acceleration a is equal to g by 3. Okay, in second case, a body of mass m, a block of mass m lifted by downward force 2 mg, downward force 2 mg. So here tension T. So its weight is always downward direction mg. So from this diagram, tension T, this is in upward direction. So tension T is equal to m into g plus a or mg plus ma. Tension T is equal to m into g plus a means T is equal to mg plus ma. This is equation 1. And this one, tension T is equal to 2 mg. Tension T is equal to 2 mg. So this is pulling force. Pulling force or tension T is equal to 2 mg. Here we substitute 2 mg. So 2 mg minus mg is equal to ma. 2 mg minus mg means mg. Mm will be cancelled. So a is equal to g. So acceleration a is equal to acceleration due to gravity. Acceleration a is equal to acceleration due to gravity. And another important model is this is a rigid support. We consider your pulley. Here three equal masses. This is A, this is B, and this is C. Having equal masses M, M, M. Here tension between them is T1 and tension between them is T2. Find the tension in between A and B and find tension in between P and C. From this one, T1 is equal to how much? T2 is equal to how much? This is also like Atwood's machine. This is also like Atwood's machine. Atwood's machine means acceleration A equal to m2 minus m1 by m1 plus m2 into g. Here m2 means 2m minus m1 means m by m1 plus m2 means 3m into g. 2m minus m means m will be cancelled. So acceleration A is equal to g by 3. Acceleration A is equal to g by 3. So this is acceleration. And also here T1 moving upwards and B and C moving downwards with same acceleration A. So from this diagram we have clearly T1 is equal to m1 into g plus A. T1 is equal to m1 into g plus a. So T1 is equal to m1 into g plus, here acceleration is g by 3. So LCM 3g plus g, 4g by 3. Therefore T1 is equal to 4mg by 3. T1 is equal to 4 mg by 3. From this diagram, T2. So here T2 is equal to the block downwards. So T2 is equal to m into g minus a. So m into g minus a. Acceleration g by 3. LCM 3g minus g, 2g by 3. Therefore, tension T2 is equal to 2 mg by 3. Tension T2 is equal to 2 mg by 3. This is also another example. And next one, contact forces. And the next one, contact forces. Another important application. So here two blocks of masses capital M and this one is small m. We applied a force capital F. Two blocks moving with same acceleration A. Two blocks moving with the same acceleration A. The contact force in between small m and capital M is F. Here small f is contact force. Here small f is contact force. From this diagram, acceleration A is equal to F by total mass. A is equal to F by small m plus capital M. Acceleration A is equal to F by small m plus capital M. Here, contact force in between small m and capital M. Here contact force F is equal to small m into A. F is equal to small m into A. Therefore, F is equal to small m into A means capital F by small m plus capital M. Contact force small f is equal to small m into F by small m plus capital M. So this application is also very important. So these are the connected bodies. And another application, another important topic in laws of motion is law of conservation of linear momentum. Law of conservation of linear momentum. Law of conservation of linear momentum. From Newton's second law, rate of change of momentum is directly proportional to external force. F directly proportional to dp by dt. Law of conservation of linear momentum means in the absence of external force, net momentum remains constant. In the absence of external force, momentum remains constant. That means dp by dt is equal to 0. No external force means F is equal to 0. So this is a differential form. When constant differentiation, we get 0. So P is constant. P is constant means momentum constant. So here consider two bodies of masses m1 and m2 moving with velocities v1 and v2. Here two momentums p1 plus p2 is equal to 0 or P1 is equal to P2 or P1 is equal to P2. So this is conservation of linear momentum. Here we have so many applications in conservation of momentum. For example, we consider a gun and bullet. So bullet of mass small m and moving with velocity small v, and gun of mass capital M and recoil velocity of gun is v, capital V. Here mass of gun are initially bullet and gun initially at rest, so momentum also constant, p1 is equal to p2. So initially gun and bullet are at rest, so initial momentum is zero. Initially bullet and gun are at rest, so initial momentum zero. From conservation of linear momentum, momentum is constant. That's why final momentum also zero. If initial momentum zero, then final momentum also zero. So mv plus capital mv is equal to zero. So small mv is equal to minus m into capital V. Here small m is mass of bullet, v is velocity of bullet. That capital M is velocity of gun, v is velocity of gun, and m is mass of gun. Here negative sign indicates that if bullet moving forward, then gun recoil back. So that's why negative sign will be there. mv is equal to minus capital M into v. So this is gun and bullet. So in that case, we have relative velocities. Find the velocity of gun relative to bullet. Find the velocity of bullet relative to gun. Here, relative velocity V relative is equal to velocity of bullet. Here, V1 bar minus V2 bar. If we consider V1 is velocity of bullet and V2 is velocity of gun, then V relative is equal to V1 bar minus V2 bar. So from this equation, small m into V1 is equal to minus capital M into V2. From this equation, V2 is equal to V1 minus V relative. So mv1 is equal to minus m into V2 means V1 minus V relative. So mv1 is equal to minus mv1 minus of minus plus V relative. So minus come this side plus. So V1 will be common. Small m plus capital M is equal to m into V relative. Therefore, velocity of bullet relative to gun. Velocity of bullet relative to gun. In that problem, we have relative velocity. That's why velocity of bullet V1 is equal to m into V relative by small m plus capital M. Small m plus capital M. V1 equal to m into V relative by small m plus capital M. And also find recoil velocity of gun. Recoil velocity of gun. In that problem also we have relative velocity. Then V2 is equal to minus small m into V relative by small m plus capital M. Here this is V1 means mass of velocity of bullet. Here we use mass of gun. Here V2 is velocity of gun. We use mass of bullet. So V2 is equal to minus m into V relative by small m plus capital M. Actually, these two applications are very important. In another applications also, same like this. We have parachute, a monkey or man climbing up a rope. Find the relative velocity of man relative to the balloon, and also a boat. In the boat in a river, a man or dog walking on the boat. So find the velocity of dog with respect to the boat, or find the velocity of boat with respect to man. In the two cases also we have same equations. We consider a parachute. Here consider a parachute of mass capital M. If a monkey of mass small m climbing up with velocity small v or moving with velocity v1, then balloon will move downwards with v2. Balloon move downward with the v2. So find the velocity of monkey. Find the velocity of monkey with respect to the balloon. So v1 is equal to v into small m plus capital M, same formulas. And also velocity of balloon V2 is equal to minus mass of monkey into V relative by small m plus capital M. And also we have another application where we consider a river. In that river we have a boat, a person. This is mass of boat. It moving backward with velocity. A man of mass small m moving forward towards shore with velocity v1. So find the velocity of man towards shore. So v1 is equal to small m into v relative by small m plus capital M, and also v2 is equal to minus capital M into v relative by small m plus capital M. Here we have velocities. In the same way we consider distances. So distance moved by the man. If man moved towards a distance d1 and both backward towards distance d2 and both of the length is capital L. Both of the length is capital L. So d1, find the distance moved by the man. So d1 is equal to capital into L by small m plus capital M. And also distance moved by the boat, d2 is equal to small m into L by small m plus capital M. These two applications are also very important. And also we consider a gun. Bullet moving like this theta. So a barrel of gun inclined theta. So find the velocity of bullet with respect to gun. Find the velocity of bullet with respect to gun. So small m is equal to capital M into V relative cos theta. V relative cos theta by small m plus capital M. V is equal to capital M V relative cos theta by small m plus capital M. And also another example is explosion of bomb. Another example is explosion of bomb. Here initially we consider a bomb. Initially at rest means U is equal to 0.
If the block if bomb blocks into two pieces. Two pieces means of mass m1 with velocity and another piece of mass with velocity v2. So bomb initially at rest means initial momentum is also zero. So m1 v1 plus m2 v2 is equal to zero. m1 v1 plus m2 v2 is equal to zero. From this equation, m1 v1 is equal to minus m2 v2. m1 v1 is equal to minus m2 v2. Here we try to keep it, madam. Important applications. Here, velocity ratio v1 by v2 is equal to m2 by m1. v1 by v2 is equal to m2 by m1. And ratio of kinetic energies. Here, so momentum is constant. So kinetic energy Ke is equal to P square by 2m. Here P is constant, kinetic energy is also inversely proportional to mass. So K1 by K2 is equal to M2 by M1. K1 by K2 is equal to M2 by M1. Here velocity is also inversely proportional. V1 by V2 is equal to M2 by M1 and also kinetic M2 by M1. So total energy is equal to total energy kinetic energy. Here kinetic is equal to P square by 2m. So P square by 2m1 plus P square by 2m2. Therefore, total energy E is equal to P square by 2 will be common. 1 by m1 plus 1 by m2. So energy E is equal to P square by 2 into 1 by m1 plus 1 by m2. And another application, disintegration. Consider a nucleus of mass number A. Here alpha moving upwards. Alpha means helium 224. Alpha means helium 224. If alpha particle moving forwards, then recoil moving up backward. So recoil of the nucleus means here remaining mass A minus 4. Here mass of alpha particle 4. Here velocity V2 nucleus, alpha particle velocity V1. So initially nucleus at rest, that means initial momentum is equal to 0. That's why final momentum is also 0. So from equations m1 v1 plus m2 v2 is equal to 0. Here m1 means alpha particle. Mass of alpha particle is 4 v1 plus mass m2. m2 means a minus 4 with velocity v2 is equal to 0. So this is also important application. And another explosion of bomb. If we consider a bomb of mass m explodes into three pieces. So then conservation of linear momentum. Initially bomb at rest. So P1 bar plus P2 bar plus P3 bar is equal to 0. P1 bar plus P2 bar plus P3 bar equal to 0. From this equation, P3 bar is equal to minus of P1 bar plus P2 bar. From parallelogram law of vector addition, P3 is equal to square root of P1 square plus P2 square plus 2P1 P2 cos theta. P3 is equal to square root of P1 square plus P2 square plus 2P1 P2 cos theta. If two blocks are perpendicular to each other, theta is 90, so cos 90 will be 0. So total value will be 0. Therefore, P3 is equal to square root of P1 square plus P2 square. P3 is equal to square root of P1 square plus P2 square. If theta is equal to 90 degree. If theta is equal to 90 degree. So the direction of P3. Direction of P3 means tan alpha is equal to P2 sin theta by P1 plus P2 cos theta. So tan alpha is equal to P2 sin theta by P1 plus P2 cos theta. And the last application. Last. And the last application, suppose a bomb projected horizontally. Suppose a bomb projected at an angle theta to the horizontal with initial velocity u. Here at the highest point, a bomb of mass m explodes into two pieces at highest point. At highest point means if block having mass m divided into two parts m1 and m2, and highest point it have only horizontal velocity. So at highest point total mass is m1 plus m2 into u cos theta. So find conservation of linear momentum or initial velocity of block or final velocity. So in this equation also we have bomb initially at rest the highest point. Conservation of linear momentum m1 plus m2 u cos theta into I cap. This have only horizontal velocity. If bomb explodes into two pieces in the same direction, so m1 v1 I cap m1 v1 I cap plus m2 v2 j cap. At highest point it have velocity m1 plus m2 into u cos theta I cap. At highest point bomb explodes into two pieces. So m1 v1 I cap plus m2 v2 j cap. Here case 1. If the two bombs are moving in opposite direction, two pieces moving in opposite direction after explosion. So m1 plus m2 into u cos theta into I is equal to, if two pieces are in opposite direction, opposite means if first block moving I m1 v1 I minus m2 v2 into I. m2 v2 into I. So m1 v1 minus m2 v2. And second case, if the first block retrace back and comes to original position. So m1 plus m2 into u cos theta into I is equal to, retraced back means m1 v1 cos theta into I. m1 v1 cos theta into I plus here minus m1 v1 cos theta into I plus m2 v2 bar. And another application, if one block moving upwards, first block moving upwards and another block moving horizontal, so then m1 plus m2 into u cos theta into I is equal to m1 v1 into j cap. If the first block moving upwards, m1 v1 j plus m2 v2 into I cap. m2 v2 into I cap. Here I cap means horizontal direction. And the fourth case is, if the first block free fall at highest point, m1 plus m2 into u cos theta into I is equal to, free fall means a velocity 0, we have only one piece, m2 v2. So these are the applications for law of conservation of linear momentum. So laws of motion is completed. Thank you very much.
How do you want to arrange them? I don't know.